For the future of gasification pyrolysis, this is a difficult question for a few reasons. One is gasification and pyrolysis systems have been developed in the past. If you look at a classic gasification system, it is the gasification of coal. And it has been developed in very, very successfully in South Africa, called the Sasol project, where they take coal and they do gasification and they yield a synthesis gas and they make diesel fuel. And they've been doing this for 50 years. Many, if not most, gasification systems are modeled after this type of technology. Pyrolysis systems, of course, have no oxygen at all. And they are completely endothermic, so there has to be an external form of heat being brought to them. Now, again, once you think about it, how things have been developed in the past and how the systems have been adapted to treat or process waste streams, they work. The big problem that has been connected with pyrolysis and gasification systems are, I would say, three prongs. The first one is, as I spoke about, the stream should be more or less pure, either all plastic, all wood, or something like this. The second one is the feeding system needs to be robust enough, because as we know, waste comes in very different sizes, shapes, densities, and so on, moisture contents, and therefore to have a good continuous feed into the process is paramount. And then finally, of course, is what is the quality of that final product gas, that synthesis gas. And of course they're related. If I have a varying feed stream, I'll have varying gas. If I cannot feed it properly at the constant rate, I'll have a varying gas. So I say all of this because to your question of what is the future of these technologies, I would say it appears that these technologies will start to take more of a foothold in the future, primarily because waste streams are getting a little bit purer, at least in developed countries. The extraction of valuable materials in the waste, such as plastics and glass and so on, paper, have rendered streams to become a little bit more uniform. And secondly, the advent of what I would consider very fast feedback control systems and solid state sensors and controllers enable these systems to be a little bit more controllable and operate a little bit more uniformly. One of the, I would call it, success stories to date is a process called the Enerchem process, where they have a commercial scale facility operating in Edmonton, where they have been able to take waste that has been already pre-processed in terms of taking out the valuables, the glass, the plastics, the metals, and so on. And that residual then goes into a gasifier that makes a synthesis gas that then goes through a catalytic process that makes methanol. And the demonstration of that system on a commercial scale has been enabled because of the sorting processes upstream that have been able to make that refuse-derived fuel a little bit more consistent. And of course, the feedback control systems in terms of how the gases are being released from the gasifier and put toward the catalytic system, and how other co-reactants need to adjust. So there's been a large development in the past. It has been definitely associated with a lot of failures, a very number of high-profile failures, but that is not because of the technology in terms of gasification or pyrolysis. It's usually because of the types of streams that they were trying to process and or what products they were trying to make. And I think those lessons learned are being well put to use with new companies and new ideas that are coming forward. So I would say it would be a slow path in terms of continued development, because pyrolysis and gasification systems have a history of being risky, but there have been a number of high-profile successes that I think are going to start to gain a little bit more traction.